Hi friends, today we'll be seeing one more important design pattern which is called strategy pattern. So the strategy pattern comes under behavioral design patterns category, and this is also one of the important design pattern which we come across in real-time applications. This strategy pattern, generally I'll tell you, I'll just show you the Wikipedia definition, and then we can quickly Wikipedia definition on the standard definition. What we say according to the core design patterns in the gang of four patterns. So there is a formal definition, and so this is a formal, and we'll be seeing the real-time example of this, so that we'll be clear on that. So what strategy pattern tells is, so defines a set of encapsulated algorithms that can be swapped to carry out a specific behavior. So defines a set of encapsulated algorithms that can be swapped to carry out a specific behavior. Okay, I'll just tell this definition in terms of an example so that it will be clear. And so in this strategy pattern, so what actually we will do is, uh, say, I'll just take a real-time example. Say I'm doing on some kind of an application or product development. It's just a general example. Just imagine, and say there is some logic where some product data has to be calculated. Okay, and for that I'll be implementing two sets of logics. So based on some parameters that are being passed, so I'll be implementing two different kinds of business logics. Okay, but the results of these two business logics again is ultimate goal is uh, calculating the product data only. Okay, but only thing is the way the logic is being implemented in two different ways. uh, so that is the scenario. We are separating this into two different logics. Okay, now in general we can call this as an algorithms. Okay, we call this as an algorithms. Okay, uh, so that means we can say I have two different set of algorithms in this example. Now what I'll do is, I'll just say generally, say for example, if based on some param 1 execute algorithm 1, algorithm 1. If a param 2 execute algorithm 2. Okay, so like this I'll be writing in my main method, in my main class. So if param 1 execute algorithm 1, if param 2 execute algorithm 2, I'll be writing like this. Now for example, tomorrow some other logic or some other algorithm comes in my application development, based on again that also based on some parameters. So like I will be just adding if param 3 execute algorithm. Now you see, whenever a new algorithm is being added, okay, I keep on actually adding the if conditions in my main class. Okay, and these algorithm 1, algorithm 2, algorithm 3, okay, they can be written in some other um, classes, and those methods can be called here, okay, in this main class. But whenever a new algorithm is being introduced, so I keep on adding the if conditions, which is actually not recommended practice, because I'm making tight coupling to this main class, and my main class keeps on getting disturbed, keeps on getting modified whenever a new algorithm is getting added. So for that actually, uh, will be, and this code is not reusable also. Okay, and for that we will actually come across this strategy pattern. We'll be using this strategy pattern in these scenarios. So that's what actually the definition tells. It defines a set of encapsulated algorithms that can be swapped to carry out a specific behavior. So that means we'll use a strategy pattern, and based on some conditions we'll be swapping. If this condition is met, execute this. If this condition is met, execute this. But we'll be not using in this kind of way. In this kind of, will not be implementing in this kind of way. So we'll be implementing using a strategy pattern, and how we can interchange the algorithms based on some conditions we will see. Okay. So for example, this is a simple UML diagram. So where we have an interface called strategy. Okay. In the interface strategy, okay, we have concrete strategy A, concrete strategy B. So assume that these two are algorithms actually. Okay. Now we have context. Okay, we'll be having some context. So context, we can say it is kind of a we can say input parameter. Okay, in this example, input parameter. So based on the input parameter, based on the context, okay, this strategy can execute concrete strategy A or concrete strategy B. It's based on the data or based on the input that I set in the context. So this strategy can switch either to this algorithm or this algorithm. Okay. So this is what actually we will be seeing. So that means what we will do is we will use this strategy pattern, and we will switch the execution of the algorithms using the strategy pattern, and we will not follow in this logic. Okay. So we'll see with an example so that it will be very clear. Now let us take an example here. Generally in our algorithms part, we will be actually using this we'll be having many sorting algorithms. Okay, like quick sort, bubble sort, selection sort, insertion sort, heap sort, so many sorting algorithms. So the final result of these all the sorting algorithms is the same, but only thing is depending upon each algorithm is having its own pros and cons. Okay, so quicksort algorithm is faster when compared to bubble sort algorithm. Bubble sort algorithm is easy to implement than compared to heap sort and quicksort. Okay, like that. So each algorithm is having its own pros and cons. Okay, so we'll be taking this example. So based on some strategy, how we can switch between bubble sort and quicksort. Okay, how we can actually switch between bubble sort and quicksort. This is simple example. In the real time scenario, also you can map to any of this. Okay, to any of your algorithms logic that you implement in your product development or application development. Okay, now let us take. I'll just take an interface called sort interface. So this sort interface is like this strategy. Okay, this sort interface is like strategy. So what actually sort interface has? It is having its own method called sort. Okay. Now I have one more class. One more. So this is sort interface. Okay. Now what I will do is I'll come to this one. We'll see now. See this bubble sort. So this bubble sort implements the sort interface. So that means this concrete strategy A is implementing the strategy interface. Similarly, concrete strategy B is implementing strategy interface. So in each concrete, either in concrete strategy or concrete strategy, we have one method called execute. The same execute method is present in interface, and these two classes are implementing this method. Okay. Now, similarly, we have in sort interface in this example, we have a method called sort. Okay, sort actually what it does, it does a sorting. On it takes an argument of a parameter of integer array. Okay, that means it takes integer array as input parameter, and it sorts all that array of integers either in ascending order or in descending order. Okay. Now, bubble sort, what it will do? Bubble sort implements the sort interface, and this sort method it will it will actually implement its own logic. But in this example, I just put SOP system.out.println. Okay, I did not put this just to show you. This video is not to show you the algorithm logic. This video is to show you how strategy pattern works. Okay, so that's why I just put a simple logic. So just this is a bubble sort. Okay, and then similarly, quicksort also, if you see, quicksort implements sort interface. So when we say quicksort implements sort interface, this is quicksort. Okay, this is sort we are implementing. Now we have written these two actually. This one, and these three. These three we have written. Now, based on the context, based on the context, the strategy has to switch either to concrete strategy A or concrete strategy B. So now we have to write this context. Okay. So what is this context is? So the context is sorter. Okay, my context is a sorter. So what sorter will do is it will take sort interface, sort interface, and it will set the sort interface. Okay, it will set the sort interface in its setter and getter methods, and it has an abstract method called do sort. Okay, now there is a my sorter. What it will do? My sorter extends sorter, and it will extend that abstract class which is called do sort, and in do sort it will call get sorter dot sort. Okay, What it does, not, it is not, what is get sorter method? Where is get sorter method is defined? Get sorter method is defined in this sorter class. If you go to the sorter class, in the sorter class, get sorter method is defined here. So what is get sorter method? Written this dot strategy. What is strategy? Sort interface. That means this is nothing but the context. The sorter and my sorter is nothing but the context. I'm setting the context for this sort interface to call the sort method. Now we'll see this is a client program. This is a client program. So where client program will call the sorting method based on this context. Now we'll see how. See, first I'm just declaring an integer array. So where the numbers have to be sorted in this way. Now what I'm doing is I'm just creating a context. This is nothing but context actually. My sorter is a context. I'm setting the context. Okay. My sorter is a context. Now what I'm doing in that my sorter, I'm just setting the sorter, which algorithm I have to execute. Okay. I'm setting the sorter. I'm setting new bubble sort. That means I'm creating an object of bubble sort. I'm setting in this context. Okay. See, generally you can imagine that you can actually take uh, see, for example, here I'm not using any if conditions. If you see here, so I'm just setting the sorter. I'm just setting the sorter based on. So see, in general real-time scenario, you can imagine like this. Say, for example, uh, I can actually, without if else conditions, I can get this new bubble sort. I can create this object in runtime, okay, based on some parameter, and I can set that here actually. Okay. Now what will happen once I set here my sorter dot set sorter? So where it goes to my sorter. In my sorter, it is which is set sorter. There is no set sorter here defined, but it is defined in its abstract class. It will go here in the sorter class. It will set sorter. What it will set sorter? Sort interface object. So in the client program, we are setting bubble sort object. So strategy is the bubble sort here. So strategy is set to bubble sort. So when strategy is set to bubble sort, so it will, so now this bubble sort is this concrete strategy A. So then, so I'll just call my sorter dot do sort of list to be sorted. Now bubble sort algorithm is called and it will sort the algorithm. Now I can set my strategy to quick sort also. Okay. Then I'm just showing for this demonstration. Okay. So my sets are do sort of list, it will be quick sort. Say for example, let us run this program so that it will be, you can see the output. Okay. Okay. Let us see. Okay, I'm just running the program. See, first time the strategy is set to bubble sort. So bubble sort algorithm is getting executed. Okay, see, for just for time being, for this demonstration, I just put the SOPs. Okay, I did not really implemented the bubble sort and quick sort logic in this demonstration. Okay, then after I have set the quick sort strategy, then it has printed quick sort. So in this way, using the context, I am setting the context to execute which strategy, either bubble sort or quick sort. So based on the context, I'm setting which algorithm has to be executed. Okay, either algorithm one or algorithm two. Like that, you can have n algorithms also to be set in the context and execute it. Okay. I think hope you are clear with this. This is actually the one of the very important design pattern that we come across in real-time projects. Okay, thank you.